that blank space, Miss Blank. All right, here we go. Systems equations, relating it back to what we did before. You can if you want to, it's okay. But now we're going to use a technique using vectors. What is a vector, Miss Blank? Anybody?
It's a line that has
both direction and magnitude. Exactly. So vectors have magnitude plus direction. For example, right? You're driving in your car at 10 miles per hour because it's your grandma. I don't know. So like 10 miles per hour is your magnitude and you're going west. There's your direction. Yay? Put all that together. That's just velocity. Sweet. Yeah? Oh. Yeah, it's just an example. So vectors is magnitude plus direction. Yay? All right. Then the bottom part is just an example of when we have vectors. Okay, here we go. Some vocab for you. A scalar, right? A scalar is usually what you multiply by something. So it describes the size or the magnitude of the vector. So, for example, some scalar quantities could be time, temperature, mass, or speed, right? Whereas a vector quantity has both the scalar and some direction as well. So velocity is a vector quantity where you have where it's going, so that's where the arrow is. So here's the initial point, and the arrows tells you where it's going. Now, the length of that line is the magnitude. So the length of your line also has something to do with that vector. Yay? All right. Me. Okay. So, couple of things. Here we go. Stuff you need to know. First of all, y equals mx plus b. Well, in algebra, lines went on forever and ever. Vectors, not so much. That size determines something, right? In algebra, you learned about y equals mx plus b, right? It had no connection to time because it was an infinite line. It kept on going forever and ever. Lines could be parallel, meaning there was no POI. POI means point of intersection. So you'll see that POI a lot. POI means point of intersection. It's all good. If they're parallel, they'll never cross. If they coincide, means one line is the same as the other line. In other words, the lines were just scalars of each other. They're multiples of each other, so there was the same line. And then if two lines do cross, they have a point of intersection. That could be easily found using some method of substitution, elimination, blah, blah, blah. Yeah? So you have the same thing. Yeah. You have the same thing with vectors, right? Except that, first of all, vectors do terminate. So there is an initial point and a stopping point. Yay? The direction matters, and you can only move with permission to time. So, for example, if this is a vector with time 1, right, adding more time to it to make the vector even more and more, the magnitude of the vector grow. Yay? Two vectors can be parallel, but they do not have to have the same length. Okay, here we go. They can coincide, right? But since there's vectors, you can coincide. There could be a point of collision, point of intersection. But you could also have two lines that are going in opposite directions, but are the S word. Does anyone know the S word? Skew. Yeah, have you heard of skew lines before in geometry? Yeah, if two lines are crossing, but they're going in opposite directions, but they'll never cross because they're on two different planes. So you can have vectors on two different planes. Oh, that's a whole other topic, right? But they might not have a point of intersection. Yes, sir. For now, we're going to do 2D vectors. I don't know if we get into 3D vectors, and I don't think we get to 3D vectors. I'm pretty sure that's just an HL thing, but we're doing 2D vectors for sure. Yay? Yay. Okay. All right, here we go. Oh. All right. So, notation of vectors, right? When you use vector notation in your IB booklet or in your test or in a textbook, the vector will be in bold. So, for example, vector A will be in bold. So when you read it, you'll say vector A to yourself, right? But since we cannot write in bold, It's impossible. We put the little notation, that little arrow sign on here. Okay? So vector A can be written as either parentheses, as brackets, or as the matrix. So those are all, not the matrix, but the two arrow things in the middle, right? With a 5, 4 in the middle. When you are writing about vectors, it's rise over run. So for example, sorry about that, run over rise. So the top one is your x coordinate and the bottom one is your y coordinate. That's what all that means. Ooh, and since there's so many ways to write it, let's just all agree on a way. I'm going to write vectors this way. Yay? So the one with parentheses, it goes x then y. Is good? Okay. Yeah, I like it that way because when we do vector addition, the x's will be together and the y's will be together. We have to add? Heavens, yes. Heavens, yes. Let's practice drawing some vectors, shall we? Right? So here's vector A, 5, 4. 5 represents the x, so the run, and 4 represents the y, so the rise. Okay? So always start with initial point, right here. And then 5 means count 5 to the right, so 1, 2, 3, 4, 5, and then up 4. 1, 2, 3, 4. So this is your end point. You started here, and your arrow will be right there. So this is your 5, this is your 4. This is a picture of vector A. Yay! Yeah. Yeah, good times. All right. Vector B. Ew. -3. What? Yeah, same thing. Here we go. Find a starting point. I'll make that darker than the other dots, right? It says -3, so -3 to the right or left? Left, yeah. So 1, 2, 3, and then up or down 4. Up. 1, 2, 3, 4. Ends here. There you go. So that's -3. That's 4. This is a picture of vector B. Yay? Yay. Okay. Last but not least, vector C. Okay. Start somewhere. From that point, move 3 to the right. 1, 2, 3, then down 4. 1, 2, 3, 4. That's the end. Start here and here. This is 3, -4. This, my dears, is vector C. Okay? Okay. Any questions so far? Any like, what you talking about? Good? Okay, let's do some math. Let's do, well, no, wait a minute. Still a couple of things left. Here we go. You want to scream? Oh, the scream. Let's see. Okay. Here we go. So some things to ponder, right? Let's see if you pay attention to the rules in the beginning. I have vectors A, B, and C. Which ones are parallel? All of them. All of them. Right? Vector A and vector C have the same magnitude, just opposite directions. So vector A is just the negative of vector C, or vice versa. Right? Vector B is the same direction as vector A, but it's twice the length. So B is twice of A. And even if they're scalar multiples of each other, they're still parallel. Yeah? So A is parallel to B, and B is parallel to C. or A is parallel to C. Therefore, A, B, and C are all parallel to each other. Again, they don't have to be in the same direction, and they don't have to have the same magnitude. Be parallel. Yay? Okay. So that long box at the bottom. Here we go. This is like the key. Put a star next to this one, because if you can't write a linear to a vector equation, we're in trouble. Alright. That's probably the most important thing for the whole page. Here we go. To convert from an algebraic equation to a vector equation. Yay? Alright. So in algebra, we learned y equals mx plus b, where m is the slope and b is the y-intercept. Yay? Okay. In vector, we have the direction and the position vector. So your slope is like your direction, and then the y-intercept is your positions. That's where you started, and then you take that slope over time. And may I also add this right here? Those are vectors. A and B are vectors. Okay, so first example, right? Let's take a look at example 1. I have example 2 right there. So in example 1, we know our slope is 3 over 5, right? And then the y-intercept is 0, 6. Yeah? So to change that into a vector equation, you ready? Here we go. Remember, vector is x over y. Okay? So the direction vector is x over y. Well, in slope, it's y over x. So you got to flip it. So your direction vector for this thing is 5, 3. Is your direction vector. Yay? Okay? T for time plus xy. So the position vector is the starting point. Right? The x is 0 and your y is 6. Okay? So the only thing that really changes is the slope is flipped. That's all. But we don't write it as a fraction. We write it as a vector instead. Yay? Yay. Yay. Okay. Here we go. This one. Right? Y equals negative 2/3 x minus 8. So a vector equation for this would be position vector, or sorry, direction vector. Oh, Heather. Yes, good. You can keep the negative with the x. That's okay. Yeah. And then t plus position vector. 0 over negative 8. Sweet. Yay? Okay, here we go. Still haven't sold it, that's okay. Alright, couple more. Here we go. What? Alright, I'll give you a second to write down those next two, and then we'll talk about it. This is 7. So it's negative 7 over 8x minus 5 over 4. All right. Ready? Here we go. Direction vector is, yup, t plus. It's not. It is what it is because this b would have to be 0, negative 5/4, right? 0 over negative 5/4. That's it. You can have fractions? Heavens, yes! It's a good time. It's a good time. Yeah? Yeah. What do we do about the last one? Good boy. Find the slope! Find the slope! How do we find the slope? Yeah. The jank? What? M is equal to? Yeah? Negative 5. How'd you do that? 8 minus 3, 6 minus 7, 5 over negative 1, which is negative 5. Yay? Okay. Okay. Here we go. So there's the slope. So r is equal to, actually that gives it to us, isn't it? Yeah, the 1 over negative 5 or something. Okay. T. Now here's the fun part. Either of them could be your position vector. Any of these points. So you want to pick either point to be your direction vector. So you can have a couple possible formulas. It's either 0, 3, or, I'm sorry, not 0, 3, 7, 3. My bad. Right? 7, 3. Or you can have 1, negative 5, t plus 6, 8. Either one would be an equation for this. Okay? Okay, now for the good stuff. Here we go. How do you find the point where two vectors meet? All right. So it's going to be presented to you as a couple of linear equations, and you're going to want to, because you have the instinct to, go ahead and do some type of algebraic way to do it, like elimination or substitution. You need to refrain from doing that, okay, to practice vectors. Change them into vectors, and then find the point of intersection from there. Super easy to do. It looks like a lot, but it's super easy to do. Okay? All right. Whew. Whew. Here we go. Use vectors to find the point of intersection. Easy day. First things first, change them to y equals mx plus b so we can find vectors for them. So this is y equals negative x plus 5, and this is y equals
3x
minus 7. You do that in your head, right? Just arrange the stuff so it's y equals mx plus b, right? Okay, so vector 1, we call this y1 and y2. So the vector for y1 is slope negative 1 over 1, sure. True? Yeah? Okay, instead of t, let's use m and n because we have two things. Okay, so m plus 0 over 5. Yay? Okay, and then vector 2 has direction other way. 1 over 3. Yep. N plus 0, negative 7. Is that true? Okay. Step 2. Set up the vertical components and the horizontal components. The horizontal components are all the x components, right? So here we go. The x's are the things on top. So your horizontal components are going to have to be equal to each other. So by horizontal, I mean negative 1m plus 0 has to be the same thing as 1n plus 0. Do you see what I did there? So basically, if you go like this, right, this should be the same thing as this. For which one? No, you are correct. You are correct. So this should be positive, this should be negative? Yeah. Yeah, you're right, you're right, you're right. They have to be the same, wouldn't they? Meh, whichever. All right. So in other words, m is equal to n. True? Okay. And then if you compare that to your vertical components, right? So for your vertical components, you set up the following equation. Negative 1m plus 5 is equal to 3n minus 7, right? And if you use this substitution on this side, just substitute that m for an n. So you're going to get negative 1n plus 5 is equal to 3n minus 7. Add the 1, add the 7, so 12 is equal to 3n. So n is, did I do that right? Nope, 4n. My bad. Okay? Divided by 4, n is it negative 3? It's 3. You know what? Yeah, Samara caught that one where we had to switch the negative to the bottom. It did? Oh, I went the other way. Yeah, I got 4 and 12. Yeah. So if 3 is n, then that means m has to also be 3. True? Okay. Now we got to plug these in, right? To the actual equation. The equations are, right? y1 is 1, negative 1, right? And m is 3, so times 3 plus 0, 5. Okay? And with vectors, if there's a scalar, then you just multiply the scalar to each component. So this is the same thing as 3, negative 3 plus 0, 5. And then when there's no more scalars, you just add the horizontals and the verticals together. So 3 plus 0 is 3, negative 3 plus 5, 2. So that is one vector. Yay. Then you plug in the n for the second part. So y2 is equal to, I already lost it. Here you go. Oh yeah. N plus 0, negative 7. Sorry, n was 3, right? Okay. So 3 and 9, is it the same? Gives you 3, 2. Guess what? That's it. So your point of intersection vector is 3, 2. You have to plug it in to make sure, because they could also, because the first part you were just checking their positions, right? But when they equal to each other, you know that they collide as well. They intersect. For two lines? Yeah? Yeah. 0 or 1, right? Because they could be skew. Yay? All right. One more. Let's do one more. What's up? Has all of them? Oh, where they're on top of each other? Not today. Not today. Today we're just going to practice point of intersection. Okay, here we go. I think this last one is the same thing, but it just has fractions in it. Don't worry. I know Trey is so excited. Here we go. All right, Trey. In your mind, manipulate it. This becomes y equals y1. Negative, you're right. Negative 1/2 x 15 over 2. Gorgeous. Gorgeous. Yeah. And y2 is 5 over 2x plus 3 over 2. Ugh. Minus 3 over 2? You're right. That's very important. Yes. Okay. So your two vectors are? Yeah. 2, -1. What's up? The whole half arrow? I mean, if you can write it bold, you're good. The only reason we put it on there is so that we don't confuse it as a variable. That's all. That's all. All right. Plus 0, 15 over 2. Is that right? Yay. Y2. 2, 5n plus 0, -3 over 2. Joy. Now what? The
horizontal
and, oh, good job! All right, horizontal components. I love it. 2m plus 0 is equal to plus 0. So again, m is equal to n. So boring. So boring. -1m plus 15 over 2. Yay, fractions! It's a fun one. Is equal to 5n plus -3 over 2. Since m and n are the same thing, -1n plus 15 over 2 is equal to 5n plus -3 over 2. Is it not -1? Yeah, the horizontal. -1m plus 15 over 2. Oh, yeah, yeah. Because m is n. So just taking away one of the variables. That would be problematic. You will not come up with that problem today. Yay? I know, Saya! Love. Sure. Sure, you can do whatever you want. You just have to get rid of one of the variables because you can only have one variable to solve it.
No, I'm just speaking for him because it wants to be represented.
Oh, it doesn't like to be substituted? Got you. Got you. Okay. Add the 3, so is that 18? Over 2 is equal to 6n. 9 is equal to 6n. 3 over 2 is equal to n, which is the same thing as m, right? They're all 3 over 2. Sweet. All right. Here we go. I know this is a good time. I'm telling you, the urge to do it the fast algebra way is going to come to you. Yeah, it's all good. It's not, at least it's not 3D vectors. Be glad for that. Yeah. I really don't think you guys do the hard 3D vector stuff. Yeah. Here we go. What do you do with a fraction? Good. 2 times 3 over 2 cancels the 2, so it's just a 3, right? And then -1 times 3 over 2 is -3 over 2, right? Plus 0 and 15 over 2. Yay? 3 plus 0, 3. -3 plus 15, 12. So it's 6. Is -6? 6. It's 6. Yes. Ta-da! What do you think the next one's going to be?
4, 6.
4, 6. Making stuff up. Here we go. Y2 is 2, 5. Uh-huh. that's a scalar, not another vector. Okay? Yeah.
Oh.
Yes. It's all good. It's all good. Plus, 0, -3/2. Joy. Here we go. All right. So that times that again is 3/15/2. True? Plus 0, -3/2. Oh, look. It happened again. Right? Yeah, 12 divided 2 is 6. Yay. So, point of intersection is 3, 6 times. Yeah. Yay? Yeah. That's the, Oh, what? Is the point? What's up? No, say it again. We good? All right, so today you're going to be asking yourself the great question, the timeless question. What do you call it when someone pays back a loan quickly? It says, solve the system of equations using an algebraic method. Ignore those directions. Practice using the vector stuff for this thing. All right, I know, Shayla's so excited. Vectors, vectors, vectors. Okay. It's on your yellow sheet. 2, 3, 4, 5. 1, 3, 4, 5, 6. Here you go, loves. 2, 3, 4, 5. 1, 2, 3. All right. If you get done in class today, you can turn it in. You won't have any homework. Yay! Is that a groan? I hear groan.